The previous videos on volumes of solids looked at these formulae to calculate the volume. Started with the prism, volume, area times height, and also included the cylinder as a special case, V equals pi r squared h. Then looked at the pyramids, volume was a third AH, special case the cone a third pi r squared h, and then finally the sphere, V equals 4/3 pi r cubed. This video is going to look at the effect on the volume of changing the radius. For example, in the sphere, if we doubled the radius, what effect would that have on the volume? Does it double it? Or what does it do? Or if we change the radius in a cylinder, or we change the height in a cylinder, what effect does it have on the volume? So take the volume of a cylinder here, V equals pi r squared h. Suppose you trebled the radius and you doubled the height. What change would that make to the volume? How would it affect the volume? There's two ways to do this. First, you could simply replace the radius by 3r, 3 times the radius. So you're trebling the radius, realising you've got to square the whole thing, and replace the height by 2h, so you've doubled the height. When you square the brackets here, you square the 3 and the r. That gives you 9r squared. And then if you sort out these numbers in red, 9 times 2 is 18 pi r squared h. The original was pi r squared h. We've now got 18 times pi r squared h. So the result was, from trebling the radius and doubling the height, we increased the volume 18 times its original. Now, the second way to do it is actually, if anything, a bit easier. It's just to assume two easy values for r and h, which would be 1 and 1. If you made the radius 1 and the height 1. So we're assuming easy numbers, r being 1 and h being 1, work out the volume. With r1 and h1, the volume's just pi. Now, treble the radius and double the height. That is, make r to be 3 and h to be 2. Put that into the formula, and out comes 18 pi, so it's 18 times bigger. So if you can assume easy values, you can actually get the change a lot easier with this second method. I'm going to show you both in some examples. So there's V equals pi r squared h. They did double the height. So in the formula, I've replaced the h by 2h, and what I do is I get back to pi r squared h by taking the 2 out of it, and it's twice what it used to be. So the volume's doubled. If I doubled the radius, I've replaced the r by 2r, but I have to square the whole thing, so the doubled radius gets squared, and that gives me 4 pi r squared h. From the original pi r squared h, it's been multiplied by 4. Here, double the radius and half the height. What effect would that have? So I replace the r with 2r, remember to square the whole thing, and the h with a half h. That's 4r squared when I break the brackets here, and the 4 is going to multiply the half, and that gives me 2 pi r squared h at the end. So it went from pi r squared h to 2 pi r squared h. The volume's doubled. So double the height, double the volume, double the radius, got 4 times the volume, and here double the radius and half the height, resulted in twice the volume. It doubled the volume. Now, exactly the same thing is going to be done, but just assuming easy values. So there's pi r squared h, make r1 and h1. V works out at pi, the volume's pi. So double the height, r1 and h2, put them in the formula, out comes 2 pi, the volume doubled. Double the height, you double the volume. So the volume went from 1 pi to 2 pi. Double the radius, that is make r2 and h1. Put them into the formula, out comes 4 pi. The volume's 4 times bigger. Double the radius and half the height means making r2 and h a half. Put that in, and this is 4 times a half, which is 2. The volume doubled. So as long as you pick easy numbers at the start, so we get an easy volume, you can quite easily double the height or double the radius, and it's still easy calculations. This is the prism turned around. For the height, it's the volume of the prism divided by the area of the cross section. So if I doubled V, I replace V by 2V, that's twice V over A. In other words, H was V over A, it's just doubled. Double A, it's on the bottom line, it's division by 2, well that's halving. So it's halving the V over A, it's halving the height. So you double the volume, you double the height, but if you double the area, you half the height. That's because the area is in the bottom line. Suppose we half the area then. I want rid of this half, I would double the top and double the bottom, and that'd be giving me 2 over 1, which is 2. So it's double V over A, and V over A was the height. So it's double the height. So double the volume, double the height, double the area, you half the height, half the area, you double the height. It's all because the area is in the bottom that the doubling became halving and the halving became doubling. To do that with easy figures, so this is the same question. Just assume V to be 1 and A to be 1, and H equals V over A, which is 1. So with these easy figures, H is 1. Double V, that is make V 2, but keep A as to be 1, and there it comes out at 2. You double the height. Here, doubling A, keep V as 1 and double A to 2. Put the figures in, H is V over A. It's 1 over 2, well that's a half. So you half the height. And here if you half A, so V's kept at 1 and A's made half. 1 divided by half is 2. If you like, you double the top, you double the bottom, you get 2 over 1, which is 2. So double the height. The same results as before, but just using easy numbers to get the answer. And the final harder case, this is the volume of a cone turned around. So the cone's V equals a third pi r squared h. Turned around, h equals 3v over pi r squared. So what would be the effect of doubling the volume? So this v gets replaced by 2v. Not working out 3 2s are 6, but taking that 2 outside to try and get back to 3v over pi r squared that we had originally. So it starts off, the height's 3v over pi r squared. I want to see what I've multiplied that by. So I don't do the 3 2s are 6, I take the 2 outside the whole thing to get back to having 3v over pi r squared, and then you can see that this has been doubled. So the height h was doubled. So if you doubled r, and then it's going to get squared, so it's in brackets because you've got to double r and then square. That gives you 4 on the bottom line. Dividing by 4 is quartering, and there I've got 3v over pi r squared, just like the original 3v over pi r squared, but it's quartered. So it quartered the height. Finally, double the volume and double the radius. So you replace V with 2V and R with 2R. The bottom here it's going to get squared. That's going to be 4R squared in the bottom and 2 on the top. So that's the 2 coming out, and that 2 gets squared, that came out as 4. 2 quarters, that's a half. So at half the height. So we're trying to reproduce 3v over pi r squared each time and see what we multiplied by. So to do this with the numbers, just make v1 and r1. It comes out 3 over pi. We want to get the other results to be multiples of 3 over pi. So if we double v, so instead of putting in 1 for v and 1 for r, we're putting in 2 for v and 1 for r. So we've doubled up the v from 1 to 2. Again, I want the 3 over pi coming out, so I just want to know it's 2 over 1 here, which is 2. So 3 over pi, this is twice 3 over pi, so it doubled the height. Second one, doubling r. Now, that's v1, and this time r's 2, but it's getting squared here, so that gives you 1 over 4, a quarter of the original 3 over pi. So we're trying to get multiples of this 3 over pi, so it's quartered the height. And this one we're doubling them both, so v's going to double and r's going to double. 2 over 2 squared. 2 squared is 4, that's 2 over 4. 2 over 4, well that's a half. So we've got multiples each time of 3 over pi at original volume at the start. Sorry, original height at the start. So, two methods. You can either assume easy figures and then carry out the doubling that you require, or you can use that method. The worksheet you can download if you click on the link in the description. It's just a similar question to what you've seen. The answers will be on it, and there are the notes. So that's the worksheet there. So if you click the link in the description, you get access, have the answers, and this set of notes you can download. It covers all the videos on volumes of solids. Hope you find the video useful. Thank you.